Okay, guys, this is a discussion on example 20.14. You will see that it's given that the Earth's electric field is downward. So you have the electric field like that, and you have now an electron sitting here, right, which is a negative charge, right? So you have, remember in our previous discussion we said, like, whenever you have a minus q charge and if you have your electric field in this direction, your force will be in that direction. So this is the similar scenario. In this case, your electric field is downwards, so your force will be upward. So that's the force, okay? And you can see in the example, they have basically found out force equals to E times E, and they have worked with just the magnitude here, so there is no arrow on top of it. Electronic charge is given by 1.6 times 10 to the minus 19, and electric field in the problem is given as 100 newtons per coulomb, so it's 100. So once we know this, we can find out the force to be 1.6 times 10 to the minus 17 newtons. You can compare the electric or electrostatic force with the weight, and the weight is going downwards, right? So the weight will be W equals to mg, and g is downward. So if we now find out the weight, you will take mass of electron, which is 9.1 times 10 to the minus 31 times 9.8 meter per second square. In newtons, this will be very small, right? So this is approximately, if you approximate these two guys to be 10, so that's like approximately 10 to the minus 29 newtons. So way smaller than what you have here, 10 to the minus 17. Once we know that, we will know the net force that this electron is experiencing is just this guy. Nothing else matters, right? So weight is virtually non-existent. If you know force, you can find out acceleration using your knowledge from 161, right? So if the force is 1.6 times 10 to the minus 17, you divide that by the mass. Again, you're going to use the same electronic mass, and this will give you acceleration, which is meters per second square. And in the book you will get, or you have got, 10 to the 13, of the order of 10 to the 13 meter per second square. So it's like fairly large an acceleration. So it's going to be pretty fast. It's going to be moving pretty fast once you have an electric field. This is also a good indication that electrons move really fast in any conductors if they are subjected to an electric field. Okay, so it's the assessment part basically going to tell you that it makes sense that it's so large an acceleration. So it's going to speed up pretty fast once the field is turned on. So we will stop here, and I'll probably upload an equation sheet tonight for chapter 20 so that you can use it or keep it handy when you are answering quizzes or solving homework problems.